Alright, so a note on how frustrating electronics can sometimes be. Let me show you what happened here for us. So, when we're measuring current, we have settings here: 10 amp, 400 milliamp, and 4 milliamp. And if we want to go higher than 400 milliamp, we have to go to the 10 amp range, where 10 amps would be your maximum range here. It didn't happen today, I don't believe. I think it happened in the past, but this is called a fuse. And there are two fuses in the back here. So if you supply too high a current level, it'll blow the fuse. So let me show you the difference between a fuse that is working and one that's not working. So on this meter here, which is my other meter, which the fuse is fine for, if we go ahead and put this on its continuity tester, which is basically an ohm meter that tells you whether you have a conductive path or not. When we touch them, it's going to make a squeaky noise. Oops, I should probably be back over here for this part. Okay, so if I go and run them for the wires here, from that end of the wire to this end, it should make a noise saying that I have a conductive path there. Let me get that hooked up. Okay, now the same thing's true with our fuses. If I put this across my fuse, it should make a noise. If I put this across the fuse and there's no noise, that means that inside of this is a really very small wire in there, that if too much current is produced, it actually breaks the wire. You can see it visually that it is broken there. So I need to buy a new fuse for my one multimeter, which I'll be doing shortly here. But I have to get that done, and in the meantime, I'll be using this other multimeter, which is not as nice, but looks like it's pretty visible for you from where you're sitting there. So I want to start this over again, and I apologize. I don't want to trust any of that previous meter's readings there. And I want to put this in the 10 amp so that I don't go above where I want to be, so I don't blow any fuses on this one. Okay, so I'll set my meter where you can see it, and we're going to go back and do the first one again, where we have our current can get to the ammeter, L2 and L3. Okay, our power supply, L2, L3, and what else do we say? L2, L3, and also the ammeter. So we want to have the negative side of our ammeter also connected. I can connect it here, I can connect it here. I'm going to connect it just right here because it's easiest with the spring there to keep it in place, just like that. So that's the negative side of my ammeter. Then from my ammeter down here, we go to L1. So from the ammeter, I'm going to hook this to L1. Okay? And then from L2 and L3, we go back to the positive side of the power supply, and it goes back across there. So we're going to connect these all up. I'm just going to take a look at them, make sure that they look like they still are in good shape of conductors. Electronics oftentimes take some patience to step back and look at things and see what you have, because sometimes it's pretty obvious. Now, a fuse is not real obvious to me because I thought it had worked before that, but you know, I turned the camera off and waited for about 5 minutes looking through the manual and seeing what the heck was going on, and that's what we came up with. So now we have all three in parallel, and excuse me, we want to take that out. We want to go back to the 10 amp range here. And so right now we are getting 0.43 amps. So I'm going to change our value that we wrote here. 0.42. Okay, 420 milliamps. Okay? Alright, so now let's go to the next one here. The next one we had that the ammeter was in series with everything. So I'm going to go ahead and I'm going to remove my power supply for my ammeter for sure. Pull that away. And it happens that our power supply comes out and goes into the ammeter. Then from the ammeter we get to everything. So I'll take these off. Power supply is directly connected to the ammeter. and then from the ammeter we get everywhere else. So I'm going to connect L2 to L1. So see what we have here now. We don't have the power hooked up to anything. Right now our power is in our ammeter here. It's running into the ammeter. It's going to run back out again. But we have all of our negative side of L1, L2, and L3 hooked up, and the positive side going back to the power supply. So now it should be the case that when I supply power through my ammeter, I have everything lit up again, and now I'm getting 1.16. So I'll write that down in here. 1.16. I'll hold that again so we can see that value in here. 1.17, 1.16, 1.16, which is in milliamps. 1,160 milliamps, right? Which is why we had to switch over for this to the 10 amp range, because we're going to be higher than the 220 milliamps. Otherwise, we blow a fuse. Okay? So right here, our current in series with everything, where it's in series with all of those. It's in the main part of the circuit here. It's not on any individual branch. The first one, we had our current on the single branch there, and we got 0.42 amps, or 420 milliamps. That was directly in line with L1. Didn't have L2 and L3 in it. Now we are in series with everything, and we're getting 1.16 or 1160, which is about 3 times as much, correct? Now they want us to measure L2 and L3. So what that's going to look like is this. I'll draw this down here where you can see it. We're going to have power supply. Comes over. Here's L3. Comes back, goes back to the positive side, negative, positive, 6 volts. And they want to measure L2. So for L2, I'm going to put the ammeter in front of it and then have L2. Okay? You don't have to draw this like this when you do a schematic. You just have to understand, and I'm trying to make it visual to you, that the ammeter is going to be in series right in front of L2 and L1. So we have 3 lights in parallel again, and we have our ammeter in series in front of L2. So what we're really doing is we're measuring the current to each one of these branches here, going through each one of those. Okay? So I'm going to take it all apart again, because I want to have you guys see how it's going together. And I apologize for the confusing broken fuse, but I didn't want to just edit that and take it out, because I don't want to make it seem like this stuff isn't without issues. You know, one thing I always look at when a student has a problem is, are all your conductors good? If they're not in good shape, then we have a problem here. So let's do this one here first. So in front of L2. So from our negative side of our power supply, it gets to L1, L3, and the ammeter. Negative part of the power supply, we get to L1, L3, okay, so far you understand what's happening. Negative we get from L1, L3, and we also get to our ammeter. So that's the negative or the positive side of the ammeter. It's going into the ammeter from the negative side. So I'll connect to right here on the L3, and I'll connect into the negative side of my ammeter. Okay? I could have connected here. I could have connected here, just as long as I had direct path from the negative. So right now we have negative goes to L1, ammeter, and L3. L1, L3, ammeter. Okay? If it goes through the ammeter, then it goes to L2. So I'll take the back side of the ammeter, the positive side of the ammeter, I'll hook that up to L2. Okay? Now, so we have everything rigged over across the side here. Now we have to have it that these all go back to the positive side of the power supply, right? So they all have to be conductively connected to one another. And then that has to go back to our power supply. And it doesn't matter where I come from. I can come from here, here, or here, because they're all right now connected. I'm just going to come from here. I'll bring that back there. Okay, so now our lights are back on again. So the current going through L2, right, because we're in series with L2. You can't see that. There you go. Current going through L2 is 0.36 amps or 360 milliamps. Okay? All right. Now, for the third one, I of L3, we have our power supply. We have our negative, positive. This comes over. We have an ammeter in front of L3 now. Right, because I'm measuring the current going through L3. So L2, L1. Okay? So now I'm going to take it apart again so we can see it. This is the last time we're doing this. Get all my wires off. And let's go through the schematic as though it's a map here. Okay, so for our negative, we can get to L1, L2, and the ammeter. From the negative, we can get to L1, L2, and the ammeter. L1, L2, and then also to the ammeter. So I'll take my negative of my ammeter and I'll connect it right here. So now I'm just connected to, and it doesn't matter, I could go to here also. Okay, I'm just going to go here because I have a little more room there. Let's see if I can hook it on here so it stays in there nicely. You know what? I will just connect it like this. Okay? So from our negative, we can go from L1, L2, or the ammeter. Okay? Next, from the ammeter, we go to L3. So from the ammeter means we're coming from the positive side of the ammeter, and we're going to L3. I'm just going to jam that in there like that. Okay? Does that make sense? All right. Next. Now on the back side here, I'll go back to the positive side. So let's get everything going back to the positive side of our battery. Okay, and bring that back to the positive side. They're all connected. That goes back here. So now we are reading 0.38 amps or 380 milliamps. So let's look at what we have here. We had IT, IL1, IL2, IL3, equal. So IT was the one we had it in series with all the lights, meaning that none of the lights went on if we took the ammeter off. And that came up with, I'm going to put everything in milliamps here, 1160 milliamps, okay? L2, we had 360. L3, we had 380. Okay, and L1 we had 420. Okay, so they're very close, those values there. But let's look at what we have now. So if we took these and added these all up, if we took, and I'll use my calculator since I have it sitting down here. $380 plus 360 plus 420 equals 1160. So in parallel, IT equals I1 plus I2 plus I3, etc. Right? So that is plus. Okay. The one thing that I want to point out to you, though, in doing this, is that we're talking about the branches. So like L1 is that branch. That's how much current's going through that branch for each one of these. Not specifically that thing, because remember, whatever else in that branch with it would be in series with it. So the current would be the same for anything that's in series, but the current would be divided between branches. Okay? All right. Just comment if you guys want to say something about how lousy my first go at this was. That's fine also. I hope you guys are doing all right. Seriously. This is not how I wanted to do this. But I have had people request that I do some more residential wiring with you. So I think that the next thing we're going to do is we're going to talk about putting switches and light fixtures over at the house across the street from here. So that'll be the next thing that we talk about, and then we'll come back to this because I do want to finish up Ohm's Law yet this year. So we have, so far, we have everything that we know now in series. We have 2/3 of what we need to know in parallel. That will have both these laws figured out. Okay? Thanks, guys.